and thanks Professor Miguel Esteban from Waseda University and Takahito Mikami from Tokyo City University for accepting to participate in this online seminar. I met them in a workshop organized by Professor Anguis at the Católica University of Santísima Concepción at Concepción City, Chile, and I really thank the opportunity to join them. An interdisciplinary knowledge is required to understand tsunamis and its effects. And I believe that these talks can help to enrich this type of point of view. Well, we can start first with the first talk from Miguel Esteban. He received his PhD in coastal engineering in Japan in 2007, and he has a very prolific work in the field. I really thanks to you for being here, and please, the audience is yours. Thank you very much.
Okay, let me share my screen. Okay, can everybody see that? The usual question with which every presentation starts.
Yes.
Okay, so good afternoon, everybody. As Marcela's just said, my name is Miguel Esteban, so I'm professor at Waseda University in Tokyo, Japan. Today, the topic of my presentation is the 2018 Sunda Strait tsunami, which is the last major tsunami. Oh, why did that move? Which is the last major tsunami that has taken place in recent times. Now, typically after each major tsunami, we organize a team of people that goes and surveys the area affected by the tsunami. So I want to introduce also the co-authors of this study. And one of them, as some of you might notice, is Dr. Mikami, who is the next speaker in this talk. Now, so we traveled to the area affected by the tsunami twice. So this is in Indonesia, and hence I'm going to give you a bit of a background of first about the area affected, the Sunda Strait. I'll be talking about the 1883 Krakatau eruption and how this eventually in other ways led to the 2018 tsunami. We did run-up and inundation surveys. We did also questionnaire surveys, bathymetry surveys, aerial drone surveys. As a result, we can map the tsunami inundation and run-up and tsunami awareness and evacuation. Why is this moving? Sorry, this wasn't supposed to move. Okay, so introduction. The Sunda Strait lies in the islands between Java and Sumatra and Indonesia. So the capital of Indonesia, Jakarta, is only a few hours drive from the area. And this Sunda Strait is home to the Krakatau archipelago, which nowadays consists of 3 main islands and a small island that has started to emerge from the sea as a result from the remnants of the Krakatau volcano. So what happened was that in 1883, so in the 19th century, there was a really big island called Krakatau, a volcano in the middle of the sea. This erupted. This eruption was so strong that apparently it was heard even in New Zealand, 3,000 miles away. And the volcano collapsed into the sea. As a result, the tsunami generated was about 40 meters high, which killed over 36,000 people. Only 3 segments of the island remained. So if you want, all of this exploded, collapsed into the sea, and only 3 fringing islands remained. The Sunda Strait was the 2018 eruption happened in one small section of the island that started to emerge from the sea in the 20th century. So most of the islands of this new Anak Krakatau volcanic island was destroyed. So this Anak Krakatau means the son of Krakatau, and why is it doing this? And it collapsed into. So most of this new island that has started to emerge from the sea, from the remnants of the old volcano collapsed into the sea in the 22nd of December 2018. And as a result, another tsunami was generated. This one was smaller than the one that was generated in the 19th century, but still it caused over 400 casualties, 32,000 people injured, and displaced almost 20,000 people. The methodology that we used in us were typical civil engineering surveys. So we do surveys of inundation heights and run-ups around the islands of Java and Sumatra. So these islands, as I said, are the Indonesian islands that surround the Sunda Strait. And we recorded the tsunami damage mechanisms. We also did questionnaire surveys. So we asked people, why did they evacuate? Where did they evacuate to? And you can see here in the lower side, one of our colleagues, one of our Indonesian colleagues interviewing local people. In the top video, you can actually see some scenes of what the destruction looked like in close to the sea. This was the last thing I explained was our first survey around Java and Sumatra, but we also did a second survey about several months later when the volcano stopped erupting in the Krakatau archipelago itself. So here we surveyed the bathymetry, i.e. how deep the sea was. We also did aerial drone surveys to obtain digital elevation maps, i.e. to understand how much of this new island had collapsed into the sea. And in this video on the top side, you can see some of these. You can see now on the right side, this new island, Anak Krakatau, and this island that you can see now here is one of the remnants from the 19th century volcano. And as you can see, the tsunami overtopped this island, destroying much of the vegetation that was there before. So surveys around Anak Krakatau. We, as I said in the previous slide, we surveyed the inundation height, and we found out that in the islands of Sertung, the tsunami had a run-up of over 40 meters, i.e. it overtopped most of the island. In some of the other islands, it had run-ups as high as 80 meters, and in the island of Rakata, only about 50 meters. As I said before, this is the island at the center is this new island, Anak Krakatau, that started to come out from the sea in the early 20th century. And this is the island that mostly disappeared due to the volcanic eruption in 2018, which generated another tsunami. We also did bathymetry surveys. Here in the video, you can see, again, Anak Krakatau, this new island, which mostly collapsed into the sea. So here you can see what was left after the 2018 eruptions. And on the map, you can see we had two boats, one small one and one big one. And we went around the islands trying to survey the depth of the sea. So this was me in this little boat going around Anak Krakatau. We also did aerial drone surveys to estimate the change in volume of the island. So in this map, on this graph on the top left side of this slide, you can see the original profile of the island in blue or red, depending on the data used. And in black, you can see the digital elevation model map that we produced. And as you can see, much of the island collapsed into the sea. So the difference between these lines is the part that collapsed into the sea. And of course, as a consequence of the volcanic eruption, also a small part of the island on the right side actually was expanded. And this is only one of the transects. And here, hopefully, you will be able to see our team. So as a result of this exercise, we were able to estimate the volume of material that was lost during the eruptions. And we estimated that to be 0.2 to 0.5 kilometers cubed. And this is slightly higher than what other researchers have were estimated in 2019 when they were trying to run simulation models. I'll go back to the surveys that we did in Java and Sumatra. compared to other tsunamis that we normally measure, this tsunami had relatively modest inundation and run-up heights. The highest inundation and run-ups that we observed were about, the highest run-ups that we observed were about 10 meters. And these were only in one very limited segment of the coastline. So for most of the coastline affected, actually the inundation heights were only 1 or 2 meters. And here on the map, you can see actually the maximum inundation heights that we recorded in different segments of the coastline. So as I said, relatively modest. Essentially, Ana Krakatoa collapsed, but the islands around it provided some shielding from the tsunami, and the amount of material that was released, that collapsed, was relatively limited compared to other tsunamis. Nevertheless, it did produce a tsunami. People did die, and we asked people why they evacuated, where did they evacuate to, and it's a whole series of other questions to try to understand people's knowledge and awareness of what they should be doing in the event of a tsunami. So, predictably, in the area, Indonesia is frequently affected by tsunamis, so 96% of respondents knew what a tsunami was. And though only 23% thought that they could evacuate in the event of a tsunami, and only 17% had joined evacuation drills. So this means that the area was relatively unprepared in the event of a tsunami, even though people had a high awareness about the events. And interestingly, almost no respondents indicated that they received an evacuation order before the arrival of the first wave. Indonesia does have like some tsunami evacuation, some buoys to alert people, but these were located in different areas. The authorities did not issue an evacuation order. So most people that evacuated did so on their own or after seeing the first wave arrive, as you can see here. When people received an evacuation order, most prepared to evacuate. Some did the usual thing, like contacting family or neighbors or seek to collect further information. Now, it is interesting to see that in one of the places that we visited, Lantera, there was, and this is the video that I'm showing here, there was a tsunami evacuation building. This is the big construction, the big tower here that you can see in this sort of orange cream color. So people in the event of a tsunami are supposed to head there and go to the top to evacuate. So, yes, people are willing to evacuate, but sadly, because there wasn't a system in the area to provide good information, mostly could not evacuate quickly. But anyway, most people did evacuate. So the conclusions are that the flank collapse of Ana Krakatoa generated a tsunami that resulted in run-up heights of over 80 meters in islands around the volcano. The inundation heights in the islands of Java and Sumatra, further the bigger islands around the strait, were maximum of 10 meters, but mostly only around 3, 4, 5 meters. The volume of material lost during the eruption was 0.2 to 0.5 kilometers cube. These islands provided some shielding. So the islands of Krakatoa provided some shielding, and the bathymetry, the complex bathymetry that resulted from the eruption of the volcano in the 19th century also played a part in reducing tsunami energy. Awareness of tsunamis is relatively high in the area, though the warning system is non-existent, and better evacuation systems really are needed in the area in case a bigger event is generated in that area. So we've published a number of papers about this already. So if you want to read more, you can go to these papers that I'm highlighting here. And yes, this is a last vision of one of the areas that was affected, showing again the potential maximum run-ups were quite high on one of the islands of the Krakatoa archipelago. So thank you for your attention. And if you have any questions, please ask me later or send me an email.
Thank you very much, Miguel. I really thanks your talk and enjoyed too much your talk. Well, the questions will be in the after the next talk. The next talk is from Takahito Mikami. He got his PhD in 2014 in Japan, and he's a young and very productive researcher. Dear Professor Mikami, it's your turn. Thank you very much.
Okay, so thank you for your introduction. Can you hear me? And can you see the slide?
Yes, we can.
Yes, perfect.
Okay, so I'd like to start my talk. So my name is Takahito Mikami, currently working as associate professor at Tokyo City University in Japan. So today I'm going to talk about the comparative analysis of triggers for evacuation during recent tsunami events. So this work is based on one of the paper we published recently. And okay, so let's start. So in the case of near field tsunami event, not the far field, but near field tsunami, that means the earthquake takes place very close to the coastline, and this created tsunami, and tsunami arrives in the coast within a few minutes or few tens of minutes. So in that kind of events, the first wave can sometimes reach the coastal communities just minutes after an earthquake takes place. So we only have very limited window of time in which to evacuate. So to have an appropriate evacuation plan, evacuation strategies, one of the important things we have to understand is what can trigger people's evacuation. So if we look at this point, there are a number of triggers that can prompt tsunami evacuation, which present at the coastline at the time of an earthquake. So here the triggers for tsunami evacuation means the environmental phenomena, information, and the behavior of people that help people realize a tsunami coming. So in this study, we focus on how different triggers we can find actually worked during each tsunami event. So the aim of this work is to understand the characteristics of these triggers in a different event, and then to understand and formulate an appropriate evacuation strategy. So in this study, we focused on the four recent, not the recent, but four tsunami events in a different part of the world. One is the tsunami in 2009 in the South Pacific near the Salmon Islands, and 2010 Chile tsunami, and 2010 Mentawai Island tsunami in Indonesia, and 2011 Tok tsunami in Japan. So these four events are located very different part in the world, and also the people background characteristics totally different. So try to understand how the different triggers work in a different background. So this is the aim of this study. So in this slide, I'd like to show the three parts as follows. The first one is to show you the actual triggers of tsunami evacuation as recorded by the interviews and questionnaire surveys. So these will be picked up from the field survey reports and classified into categories. So as Professor Esteban said, so we always did a field survey just after some tsunami event occurred. So we visited all of these events, but also to understand the more detailed picture of each event, we also look at the field report or field observation results from different survey teams. So nowadays there are many international survey teams for a tsunami event. So we can share many very good results after a tsunami event. So we use these results for this study. And second, the principal triggers. That means the major triggers that help people realize a tsunami coming will be identified and contrasted with the characteristics and backgrounds of each of the areas at the time of the event. And the last part is to see the relationship between the principal triggers and the characteristics and backgrounds of coastal residents. Okay, so let's start from the first point. So what we did first for this study is to pick up what types of triggers actually worked during each event. So we look at the field survey reports, observation reports from different survey teams. So here is a table showing the triggers that were observed during each survey teams. So for example, so this is the case for the Salmon Island tsunami in 2009. So one of the reports said that the feeling the earthquake or noticing some activities of the sea, or in some cases, bells and gongs run by the local mayor help people try to evacuate. And another report said there are another type of triggers for evacuation. So we gathered this type of information from a different survey report, observation report. So these are the case for the Salmon Island tsunami in 2009. So there are another references. So we did this type of work first for 2000 Salmon Island tsunami, 2010 Chile tsunami, and 2010 Mentawai Island tsunami. And then we can summarize that the triggers for tsunami evacuation can be categorized to 1, 2, 3, 4, 5, 6 different types of categories. So one of the first triggers that can be observed during near field tsunami event is of course feeling the ground motion. So if the people have knowledge that the earthquake can generate a tsunami, so the feeling strong ground motion in the coast can trigger people to decide to evacuate. And also many other reports said that the seeing other people's behavior, like the people starting moving to higher ground, or hearing other people's warning. So these are another type of triggers. And also when tsunami comes to a coast, sometimes some unusual behavior of the sea, like receding the water or breaking at the offshore. So this can be another trigger. And in some cases, some reports said that the people hearing a loud sound and then feel something happens, then decided to go to higher ground. So this is another type of triggers. And also, of course, receiving a message from the authorities about the tsunami warning or evacuation order. So this can be another type of triggers. So we can categorize the triggers for tsunami evacuation like this. And to understand what type of triggers especially work for each area, we need to look at some more detailed data which shows the people's behavior in each area. So this is one of the examples that can tell us the detailed behavior, especially what type of triggers can work as a major principal triggers. So here is the questionnaire survey results on the triggers of tsunami evacuation during 2011 Tohoku tsunami in three prefectures, Iwate, Miyagi, and Fukushima. So which were the most affected regions during the 2011 tsunami. So in this case, you can see that the feeling ground motion or receiving a tsunami warning that can that could work as a major triggers in each area. So this is the results for other prefectures, which were less affected compared to the three prefectures that I showed you in the previous slide. So here you can see the somehow another result. So in this case, more people use the tsunami warning as a major triggers for evacuation. So anyway, you can see that each area has a different trends in terms of the major triggers for tsunami evacuation. So we looked for this type of questionnaire survey results for other tsunami events in Samoa, Chile, and Mentawai, and try to illustrate what can be considered, which can be considered as a principal triggers in each of the areas. So this table shows the summary of the principal triggers in each area. So you can see that each area has a different trends in terms of principal triggers. So for example, for the case of Salmon Islands, the major triggers worked during this event is seeing other people's behavior, or hearing other people's warning, or feeling a tsunami wave. That means the tsunami arrived the coast and then decided to evacuate. But of course, if we look at the other events like Chile, so many people decided to evacuate after feeling the ground motion, or seeing an unusual behavior of the sea made people decide to evacuate. So anyway, we can find very different picture of the principal triggers in each area. So the next thing is to understand why this difference can be observed, to see the characteristics and the backgrounds of each area. So we have two different points to illustrate the characteristics and the backgrounds which can affect the behavior of the people. So one is how tsunami warning system work, and the other is how frequent each area experienced a tsunami event in the past. So anyway, I skipped the detail of this table, but what I want to mention is that the tsunami warning system, the progress of the warning system is different, and also how frequent they experience a tsunami are also different. So anyway, based on these characteristics and backgrounds, we can see that so regardless of how frequent they are exposed to tsunami, the feeling the ground motion worked as one of the main evacuation triggers for many people, almost all cases in this study. So it may be resulted from the many educational and awareness raising activities, especially after the 2004 Indian Ocean tsunami. But also we can see that, for example, in the Salmon Islands or Mentawai Islands, still some people in these islands evacuated to higher ground only after noticing last-minute natural signs. So in these cases, for example, for the case of Mentawai Islands, the tsunami came to their islands at night, so it's difficult to clearly see the surroundings. So only the sound is one of the main information they can understand the current situation. And compared with the other areas, the more people evacuated after feeling the ground motion in Chile and the Miyagi, Iwate, Fukushima in Japan, which were the most affected areas during the 2011 tsunami. So these findings highlight how past experiences and basic knowledge about tsunami had been passed down from generation to generation in these areas. So compared to other areas, Chile and Iwate, Miyagi, Fukushima, they have more tsunami events, especially in these 100 or 200 years. So several tsunami events occurred in these areas. So in these cases, more people know the basic knowledge about earthquake and tsunami. So that eventually connected to this result. And one more interesting thing we can find here is that in other places in Japan, so people in this area relied more on the messages from the authorities, that means the tsunami warning messages or evacuation order, than the Iwate, Miyagi, and Fukushima prefectures. So this finding indicate that in areas with repeated past tsunami experiences, many people realized that they only had limited time for evacuation after the earthquake. So they didn't wait for a tsunami evacuation, but they decided by their own to go to higher ground just after feeling the ground motion. So this is the last slide. So as I showed you, the basic knowledge about tsunami had been spreading, which triggers many people to evacuate soon after feeling the ground motion. So this almost regardless of how frequently each area had experienced tsunami events in the past. However, as some people in areas with less past experiences only evacuated after noticing last-minute signs, and there is a non-negligible number of visitors present in the coastline of certain communities. And in areas with less past experiences, people were more likely to tend to wait for messages from the authorities to decide to evacuate. So this highlights the importance of teaching local residents and also visitors how a tsunami can reach a given area in a relatively short period of time, even before the tsunami warning arrives. So this is some of the important thing I like to say as a conclusion. And as I mentioned, this presentation is based on the paper we published just last year. So some of you want to look at the more details about this study, you can refer to this paper. Okay, thank you for your attention. This is the end of my presentation.
Thank you very much, Takahito Mikami. Well, now is the time for the questions round. Perhaps we have one question from Juan Gonzalez to Dr. Esteban, and he asked to you, could you share your experience in organizing a post-tsunami survey coordinated with multiple organizations such as university and local public institutions? Thank you in advance.
So, yes, I mean, obviously, doing something like the kind of things that Dr. Mikami, myself, and other people do, it takes a lot of course, organization, logistics. You need to have funding. obviously this is often a problem. But for me, often the biggest challenge is actually finding a good local counterpart. If you already have a good relationship with somebody in an area, an established partnership, then things can be quite easy. But finding often this good local partner can be a difficult thing. In some countries, people are not so interested in the field work, or they might not, like some people work in universities, but they're happy just to do their teaching, or they might be happy to do research, but they prefer to do it in front of a computer. So finding these local counterparts who know people, who know how to do things in the country, and who are interested is the main key component of doing these things. So fortunately, through the years, through former students of that are in the same lab as myself or Dr. Mikami, we have a network of people around the planet who we can often tap into when these things happen. So if you want to do these things in the future, I mean, I think one of the first things is to go to conferences and to talk to people, and after the conference, after each conference day, to go and have dinner with people and establish this friendship that then allows you, when these events happen, to talk to these people and say, right, we're going to do this field survey. We're arriving on this day with so many people. And then normally, if you found this enthusiastic local partner, they will say, great, I'm mobilizing my people as well. And the survey turns out to be good. So I'm not sure if Mikami wants to add anything to this.
Okay. So and also I think maybe it's important to find good students who are interested in our study. So maybe one of our strategies to show, okay, we are now doing this, or we are doing this field survey, this work with some people in the foreign countries. So showing the results or showing our actions, activities to the students, some of the students feel, okay, this is very interesting. I would like to participate, and I'd like to have a chance to also do the same things. And generation to generation. So if we can find a student in this batch and next batch, then we can continue our work very sustainably, continuously. So this is, I think, other point, other important point to do this type of work.
Thank you. We have another question from Constanza Flores. To both of you, if you want, in your opinion, what are the biggest challenges to implement an early warning system in the place of study? Thank you.
You want to go first, Mikami?
Well, so where
you can read it if you want. Okay, you can read it, or I can say it again.
Yes, please.
Okay. In your opinion, what are the biggest challenges to implement an early warning system in place of study?
The warning system. So for the case of tsunami, sometimes the early warning system worked, but also in some cases didn't work because in some areas the tsunami reached just 5 minutes or 10 minutes after the earthquake. So of course we need to have an early warning system, and this actually can help people to evacuate. But we have to look at the system, if it's system or program, which can help people realize the risk of tsunami by their own. So anyway, there are many maybe technical issues to how to implement the warning system, but also to reduce the total loss of the damage in terms of evacuation. We need to understand maybe other point. like what I mentioned here. So, Miguel-san, is there any other point?
Yes, I mean, for the case of Indonesia also, I mean, of course, the points you say are very important. For the case of Indonesia, of course, there's an additional challenge, and that sort of came to mind when we did all field work, is that all this requires funding, right? And for the case of Indonesia, for example, funding is kind of limited. So when they installed their early warning system, they were doing it for expecting a tsunami from the south. We also heard evidence from people there that not all the buoys in the sea had been properly maintained. Some of them had been robbed of essential components. So this is kind of a challenge when you're talking about developing countries. You have something in the sea, we have all these little fishermen with boats that can go and take out equipment and maybe sell it just as scrap metal. So I remember this is a challenge for Indonesia and maybe some other countries in the region. Like it's not just installing something, but maintaining it. And then, of course, everything else that Dr. Mikami said.
Okay. There are a question from Jorge León to Dr. Mikami.
Okay.
I read it. Thank you for your presentation. Did you have the chance to examine asymmetries in the population's behaviors within each case of study? For instance, during the 2010 tsunami in Chile, it was pointed out that the tourists behave rather differently from the local people during the evacuation.
Yes, so this is the important point. So for the case of Chile, many of the victims were the tourists who stayed in the campsite or some areas very close to the coastal line or river line. So how to reach these type of people is of course the important, and also the same problem can be found even in Japan and other countries. So, for example, Professor Esteban and their colleague work in Kamakura City recently. So, which is one of the very famous tourist or visitors destination in Japan. But also that place has a tsunami risk. Maybe 10-meter tsunami can reach that area within 5 or 10 minutes after the earthquake in a most serious scenario. So in that case, maybe, for example, if the tsunami takes place in summer, maybe the southern or more people in the coast, so and they maybe don't know whether there is a tsunami risk or not. So I think maybe in many areas in the world have the same type of problem. So they have not only the local people, but the many number of the visitors or tourists. So this is another challenge in terms of the tsunami evacuation strategies in the coastal area. Yeah.
Okay, thank you very much. Miguel, do you want to add some comments about that, or we have two more questions?
Just a small thing to add to what Mikami said. Essentially, yes, what he said. And also to answer to the question of Jorge Leon, you have to also differentiate between local tourists and international tourists. So we found that, for example, for the case of Kamakura, when you do international tourists and local tourists, their awareness is different. Local Japanese tourists, of course, expect a tsunami. International tourists know that tsunamis happen in Japan, but they expect that local people are going to help them or something along these lines. And for the case of Kamakura, actually, it's a very complicated evacuation case because there are no defenses. So we did some questionnaire surveys amongst international tourists, and it's clear that their idea is different to local tourists. So this is also something to consider to further that point.
Okay, thank you very much. We have another question from Adolfo Balboa Monroy for Mikami. In Japan, are evacuation routes for tsunamis designed and implemented in the normative plans of urban planning of urban areas? And how has progress been made in the vertical evacuation of existing buildings in a massive way? For example, in Tokyo.
Okay, so yes, now especially in Tohoku coastal area, which were affected heavily in 2011 tsunami, so they have very well designed tsunami evacuation strategies. That means they're including the evacuation route and the evacuation destination and the educational program as well. So and vertical evacuation. So in some cases, so of course the evacuation destination, the best evacuation destination is the higher ground, the very high enough, the hills or mountains or something like that. But in some areas, the coastal area is very flat. Elevation is just 2 meters, 3 meters above the mean sea level. Even we go into the 300 meter, 500 meter from the shoreline. So in that case, our choice is to have vertical evacuation using tsunami evacuation building or tsunami evacuation tower. So in some cases, we have tsunami evacuation building, but the one of the problem we have is in some coastal areas they have some restriction, so they don't have permission to build a tall building, mainly because of some maintaining a good scenery in the coastal areas or some maintain traditional scenery, so they don't want a very high rise building, even 4 story or 5 story. So in that case, still we are looking for how to do a vertical evacuation in such place. So anyway, so the basic idea is that the very flat, low-lying ground, we have to consider vertical evacuation using a tsunami evacuation building or tsunami evacuation tower. And fortunately, Tokyo, the expected tsunami height is not really high. So I think, for example, for the case of Tokyo, we don't need a very high number of evacuation building, and Tokyo still already have many buildings which can resist during tsunami or the strong earthquake. Okay, so this is the comment for the question.
Thank you, Miguel. Do you want to add something about that?
Well, just to say something then, I mean, and to follow from Mikami's comment, yes, in Tokyo, the big problem really isn't tsunamis, it's storm surges. And the question becomes, in certain areas of Tokyo, which are below sea level, if the levees are broken, and at this point, the Tokyo government and the government of Tokyo and national government is implementing these super levee projects where you raise entire districts to become levees and you build high-rise buildings on top. So if there is a storm surge, people can evacuate to those buildings. But as Mikami said, for the case of Tokyo, tsunami isn't really the thing. There is a tsunami risk, but the defenses are probably adequate, and if it happens, it will be limited. Storm surges are the bigger problem.
Okay, thank you very much. Well, here is a question from Rafael Aranguis. In Chile, we have ancient knowledge regarding earthquake and tsunamis from native people, Mapuche people. But unfortunately, it has not been spread among other people and authorities. Have you found this kind of knowledge in Japan and Samoa during your field surveys?
Okay, so in Japan, yes, there are some memories maintained in local community, especially in Tohoku or other places which have many past tsunami events. So, for example, in some village, they have a monument in the middle of the mountain, so which tells us the so you cannot so you are not allowed to build the houses below this level. So that means the tsunami reached this point at some past tsunami events. So this can show us the actual expected height of tsunami in that village. And also there are many other examples you can find in Japan. But also the problem that this type of knowledge is somehow maintained, but uh, in many cases, for example, the places which have a tsunami event in 200 or 300 years ago, and since then there is no major tsunami event. So in that case, people very easy to forget these experience or stories in such a very old event. So frequently attacked area like Tohoku, they can maintain some memories or lessons from the older people. And in other places like Samoa, so we did some field survey, and there is a record that the tsunami happened in almost 100 years ago, but nobody said there is a tsunami in this place. So all of them said that this is the first time to see this. So we are taught about the tsunami in a school, but this is the first time to actually experience a tsunami. So in many areas, they don't have some lessons learned from their original place or older people. So I'm very interested in how Mapuche people in Chile have some knowledge. So Rafael, sometimes please show us what Mapuche's knowledge in Chile. I'm very interested in this type of things.
Okay, thank you, Miguel, Esteban, if you want.
Just to add another nuance to this, I mean, for the case of Japan, and for example, if you consider the 2011 tsunami, the Japanese government had spent decades preparing for it. So in essence, they were expecting a tsunami. It just happened to be much bigger than what they had been planned for. So I don't think that they had ignored traditional knowledge in a sense. It's just that the magnitude of this event was so huge that it overwhelmed all defenses. The deepest tsunami breakwater, the breakwater built in the deepest water anywhere in the planet was in Japan, and it was designed specifically to protect against tsunamis, a very expensive structure that was partly damaged in 2011. So, I mean, they were really taking care of this event. School children had been told how to evacuate. In some places, 10% of people died, but is 10% good or bad? Is the glass half full or half empty? Depends on whether you think the event could have killed a lot more people if the government and society hadn't spent so much time and effort preparing. So it's a complicated one. If you visit the affected area, you sometimes think like, well, it's amazing that anybody managed to evacuate at all. When you stand in a set, for example, at the top of a hill, and you know that the tsunami reached the top of that hill, you think, how could anybody even find the time and effort to evacuate? So it's difficult when you come to traditional knowledge. One way of thinking would be that actually the Japanese government had listened to traditional knowledge. Another way would be to say that they hadn't listened enough. But yes, it's a difficult one with these questions. Thank you.
Thank you. Thank you very much. We have not questions. If we have not another question, we can finish this webinar. I really thanks too much Takamicho Mikami and Miguel Esteban to join us also, and we thanks in behalf of the university so much your attendance to this webinar. Thank you very much, and thank you very much to the audience and all the people that interested and ask questions, and thank you to all.
Okay, thank you.
Thank you
for having us.
Okay, thank you. Bye. Thank you.
Bye.
Bye.
Oh. Okay, thank you.
Thank you, Professor Mikami.
Yeah, I very enjoyed. Thank you for organizing this webinar. So see you.
Don't worry.
Yeah.
We hope to have you again very soon.
Yeah. I hope so.
Have a great day.